So suppose guys, there is a capacitor charged to, let's say, charged to a charge Q and then connected to a pure inductor. Of self-inductance L in series. So basically what exactly am I doing? There is a inductor over here, pure inductor, no resistance involved anywhere. Please remember, when a resistance will be there in this case, then energy will start dissipating out. The energy will start, decrease, keep on decreasing. So I have a charged capacitor and charge is minus Q, and let me just I need to connect a switch as well. So now tell me, initially when the charge will be there, this is not active, okay? Inductor is not active right now, only the capacitor is completely charged. Now what will happen if I close the switch at t equals to 0? If the switch is closed, then what will happen? Initially, what was the energy form? What was the form of energy initially? Guys, what was the form of energy initially? Initially, the energy stored in electric field, right? Can you see?
Yes, sir.
The electric field between the plates, it has certain energy. So whatever energy is there, it's stored in the form of electric field in between the plates of the capacitor. Now what happens at t equals to 0, as soon as you connect them, now what will happen? Now this plate and this plate can come in contact with each other, right? So this is at higher potential, this is at lower potential. Can I say a current starts flowing through this loop like this?
Yes, sir.
And will this current be increasing or decreasing? This current
It will decrease.
It will increase, no? It will be increasing current. वो बात
Oh
की दिक्कत
yeah.
है ना? So the current will be increasing current. When this increasing current will be there, this inductor will say, no bro, I won't let you increase. So what will it do? It will try to oppose it. Yes or no?
Yes, sir.
I'll write the whole thing. At t equals to 0, when the switch is closed, the capacitor will start discharging and a current starts in the circuit. Now if I say, if at any general time, if at any general time t, the current in the circuit is small I, the charge on the capacitor is Q, and basically what is happening? This will start opposing. The current will be I, and the charge remaining on the capacitor will be how much? Q. Can you see over here? Capital Q was what? What was capital Q? Capital Q was the initial charge, right? Or at t equals to 0, can you tell me at t equals to 0 what was t equals to 0 पे current कितना होगा? At t equals to 0, the current in the circuit will be 0 and the charge will be plus Q. But जैसे जैसे time जाता रहेगा तो the charge will start flowing, no? Or we can say a current will start flowing, right? Yes or no? So
Yes,
basically these things will be acting as your limits जैसा काम करेंगे. So anyways, Can you apply this thing? What is the total energy at any instant? What is the total energy? Can you see, is there any resistor over here which is involved? Is there any resistor? Is there any resistor over here?
No.
So will there be energy dissipated?
No.
So यहाँ पे क्या हो रहा है basically? Can I say this particular thing? कि since there is no resistor involved, since there is nothing which can dissipate energy, only I have a L and a C connected in series, है ना? So which can dissipate energy, that implies the total energy of the system, let's name it as E system, will remain constant. And what is the total energy of the system? So there is, when the charge is Q, there is some energy over here, half Q square by C plus half L into, what was the current at this instant? I square. Yes or no?
Yes,
Will
sir.
this be the total energy? Acha, will this be constant? What will this constant be equals to? Will it be equals to half Q square by C? Because initial energy was this only, no? Plus 0. Initially, I didn't have active inductor involved. The inductor was nothing. Inductor was just there. Yes or no, guys? Can I say it like this? Just remember this part. Okay. If it would have been an active inductor and an uncharged capacitor, then this would have been become 0, and this would have become half L into I naught square. Are you getting my point, guys? Yes or no?
Yeah.
So basically क्या होगा यहाँ पे?
Yes,
So
sir.
what will happen? Energy will keep on dissipating, but that energy will keep on flowing in this thing, due to which the current will be increasing, and whatever energy is filled over here, it will start changing its form to magnetic field energy. So basically what will happen? So after a certain time interval, all the energy stored in the capacitor will get stored in the inductor. Are you following the kahani till now?
Yes, sir.
In form of what? Basically energy has changed its form. Earlier it was in the form of electric field energy, now it is in the form of
Magnetic field energy.
magnetic field energy. And let's say this time is say the time is t dash. Okay, so after a time t dash, what was happening? The energy changed its form to, not after t equals to t dash, in time interval t equals to 0 to t equals to t dash, energy changed its form from electric field energy to magnetic field energy. Yes or no? Yes or no? So what will happen at this instant? The inductor will become, the capacitor will become fully discharged. Yes or no? The charge on the capacitor becomes 0, and the inductor became fully active with a current I naught, with a maximum current I naught. So here my capacitor at t equals to t dash, capacitor is completely discharged, and inductor is fully charged with, let's say, maximum current I naught. Yes or no? Arey, yes or no?
Yes, sir.
Yes, sir.
Now this inductor will start behaving as a what? This inductor will start behaving in spite of I naught over here. I am writing I naught over here. Why? So that you will understand that this inductor it starts behaving as a active inductor and will start supplying the current. Now this inductor behaves as, are you writing with me, guys?
Yes, sir.
Okay.
Yes, sir.
So if this inductor behaves as an active inductor, then what will happen? It will start supplying current in the circuit, and when it will start supplying current in the circuit, what will happen? The
Capacitor will
capacitor will
get
start,
charged.
exactly, which the capacitor gets charged again. Now very importantly, notice this particular thing. See, when the inductor was behaving plus minus, the current was flowing in this direction, yes or no? As soon as this thing gets completely discharged, the current is still in this direction, right? Due to what will happen? Due to what will happen? Now the plate which was earlier negative, it will start becoming
Positive.
positive. So capacitor gets charged again, but in the opposite polarity now. So basically, what will be the scenario after this? This current I naught will start decreasing again, and this capacitor will now get charged with this as the positive plate Q and this as the negative plate minus Q. And let's say the general current inside the circuit flowing is small I. Are you getting my point? After a time 2t dash, what will happen? After another t dash interval, that is from t equals to t dash to t equals to 2t dash. You remember t dash?
Yes, sir.
Please remember, it's an oscillation that will be followed with 4 cycles, right? Quarter cycles. Do you remember whenever we talk about any cycle, ये oscillatory motion होता था जब भी? Everyone remembers this oscillatory motion? From mean position it goes to the extreme, then from extreme it comes to mean again, from mean it goes to another extreme, and that another extreme comes back to mean. Yes or no?
Yes, sir.
So basically this time t dash is nothing but t equals to 0 and then t equals to t dash. Then from t equals to t dash to 2 equals to 2t dash. 2 equals to 2t dash, then 3t dash, and similarly when it will come back it will be 4t dash. Are you getting my point? So the same way, here the energy is oscillating. The thing here, the physical pendulum was there, but in this case what is oscillating? The energy is oscillating. So in this case what will happen after another time t dash? What will happen? The inductor will become completely discharged and the capacitor will get charged with the same charge
But opposite polarity.
plus Q and minus Q. Do you remember Q? Capital Q. So at t equals to 2t dash, time instant जब इतना होगा, then inductor completely discharged and capacitor completely charged but with reverse polarity, right? Yes or no, guys?
Yes,
Now
sir.
what will happen? Now what will happen? Will this is the cycle complete now? Is this the same way where we began with? नहीं ना, ये तो बीच में आके अटक गया. initially we began with plus q on the left plate and minus
Yes,
q on the
sir.
right plate. So basically अब क्या होगा वापस से now the same cycle will repeat, but now the current will start flowing in what direction? Now the current will start flowing in this
The
direction,
clockwise.
clockwise direction, anti-clockwise direction, right?
Yeah, sorry,
So,
anti-clockwise.
so current will start flowing in anti. Can you tell me what will be the case on at t equals to 3t dash? Now the current starts flowing like this, and when the current starts flowing like this becomes positive and this becomes negative. Now at t equals to 3t dash, again this will be the current. The capacitor will get completely discharged. Are you getting my point? And at t equals to 4t dash, what will happen? This thing will get completely discharged again, and this will get charged back to where it was. Yes or no, guys?
Yes, sir.
So basically, you can understand this particular thing. This is a 4-cycle process, that in 4 different intervals it came back to the where it began from. So that's why we can say this particular thing here. Here, energy of the system keeps on oscillating between the electric field energy inside the capacitor and magnetic field energy inside inductor. So this type of oscillation of energy is basically called as LC oscillation. Is this clear, guys?
Yes.
And please remember, if there will be a resistor, then automatically every time the resistor will be there, current will be flowing and some energy will be dissipating. Those kind of oscillations, when a resistor is present, that is damped oscillation. Do you remember? Everyone, SHM, free oscillation, forced oscillations, damped oscillation.
Yes, sir.
So free oscillation is basically this, where there is no energy loss. If I introduce a resistor over here, then energy will keep on reducing forever, right? And those will be called as damped oscillations. Also note, energy of the system, E system remains constant. So always half Q square by C, half L I naught square is equals to half Q square by C plus half L into I square. Can anyone interpret this for me? What is this? This is the energy when the whole thing, when the complete energy is in the form of, when the complete
Electric
energy is in
field
the form
energy.
electric field energy. This is the energy when it is in the form of magnetic,
Magnetic
Magnetic
field.
and
field.
this is at an interval in between both of them. Q is a general charge and I is the general current. Are you getting my point?
Yes, sir.
So remember this. Acha, from here I can calculate the value of I naught as well, na? If suppose initially Q is given, so you can calculate I naught. Half and half will get cancelled, and can I write I naught will be equals to Q square by LC, and then I'll take square, so Q by under root of LC. Will this be the relation between I naught and Q? Please remember, initially only one of them was charged. If initially some charge is already there, energy is already there, so you know how to do the whole thing now. Enough? Go with the same process. Total initial energy, total final energy should be equal. No energy loss should be there. And accordingly we'll solve. Is this clear?
Yes, sir.
Okay. When will be the current maximum? In terms of energy, how will you say it? When will you say the current is maximum? No. Guys, when will you say the current is maximum when all of the electric field energy has been converted to
The
magnetic field energy?
magnetic field energy.
तब उस टाइम पे करंट मैक्सिमम हो जाएगा. Yes or no? Is this clear?
Yes, sir.
Now, shall we start analyzing the equation, or shall we start the analysis of LC circuit, the mathematical part? This is not the mathematical part. This is the what is LC oscillation I told you. Okay. The mathematical part will start now. लिख लो. Whenever you're done, just tell me. अच्छा, कल तुम लोगों को एक सरप्राइज मिलेगा. अरे भाई, तो मैं अभी दे सकता हूँ, जाने दो, कल ही मिलेगा.
Tests?
ना ना, not test.
Something morbid like that?
Yeah, not. You can't say it morbid. Come on. टेस्ट नहीं है, दूसरी चीज है.
Saqib sir is back?
अरे हट.
I'm just guessing.
ना ना, यस. तो कल सरप्राइज मिलेगा क्लास में.
Okay.
यस.
Chemistry sir is changed.
अरे नहीं रे, केमिस्ट्री सर तो तुमको अभी क्लास ली नहीं क्यों अभी तक? हाँ, कल ही तो आया हूँ. राइट.
Kunal sir went to India.
हाँ, everyone went to India, no, except Pradeep sir. Pradeep sir was here only, whereas me, Jet sir, and Kunal sir, we went to India.
So what is it?
What is it? कल बताएंगे, कोई दिक्कत नहीं. Let the suspense be there. ना.
Sir, we have to come to.
No coming to the center. Online. Mystery and suspense should always be there. Anyways, let's start. So heading डालो. Analysis of LC circuit. लिख रहा हूँ मैं. Analysis of LC oscillations. Because no one asked me this particular thing. Sir, you taught us RC, you taught us RL, but what about LC? Nobody asked this, no? And what about LCR? LCR is out of the syllabus. LCR with DC supply is out of syllabus of JE as well. LCR with AC supply is there. Alternating current supply is there. Okay?
Yeah.
Okay, so
this is out of the syllabus, but ये पढ़ा दिया, उसके बाद अब ये पढ़ा रहे. So can you see? This was taught in current electricity. ये अभी पढ़ा है, ये भी अभी पढ़ा रहे हैं. Although ये AC circuit में पढ़ाते हैं, but you people will unnecessarily get confused in the AC over there and here. So that's why I didn't teach it over here. That's why I teach it over here only. So anyways, analysis of LC oscillations. Suppose initially I have at t equals to 0, I have a capacitor completely charged. I told you it doesn't make a difference. I could have charged, I would have, could have made this inductor as active initially, but दोनों में से एक में तो किसी में we need to take the energy. So generally I take capacitor, it's easy. So suppose this is plus Q and this is minus Q. So the charge on the capacitor is Q, and if you have pressed the switch at t equals to 0, now what will happen? The current will start flowing in what direction? The current starts flowing in this direction. Yes or no? Due to which this is positive and this is negative. So now at any general time t, if I say the charge on the capacitor is, let's say, plus Q, and here it is minus Q, and the inductor becomes, the current through the inductor is, let's say, I. The current through the inductor is, let's say, I. What is the EMF across this? The magnitude of EMF is basically L into di by dt, right? Yes or no? What is the total energy of the system? The total energy of the system under ideal situations. Please remember, no resistance anywhere. So under ideal situations, will it be equals to half small q square by c plus half L into I square, and will it be constant? Yes or
Yes,
no?
sir.
By energy conservation, will this thing be there? Yes or no? And what is this constant equals to? This constant is equals to half q square by c. We know this constant, right? If I
Yes,
just
sir.
differentiate this part, differentiating, let's say with respect to time, so half and c is a constant, right? So 1 by 2c will be out. What is the differentiation of q square with time?
2q
2q
with q
into
dq by
dq by
dt.
dt.
2q into dq by dt. This is in accordance with chain rule. If I would have been differentiating with respect to q, then this term would not have been, would not have joined us. But since we are differentiating with respect to a new variable time, so we differentiated assuming this as something. So something square differentiation is twice of something, and then differentiating that something. Are you getting my point? This is in accordance with chain rule. Okay, chain rule of differentiation. Similarly, half into L into, now what is the differentiation of this?
2I into di by dt.
2I into di by dt. Very good, you catch it very quick. And what is the differentiation of a constant?
0.
0.
So can you see, half से ये 2 cut मारेगा, this and this will get cancelled out, and will it be something like this? Can you solve it for me, please? Can I write this as L into I into di by dt? Yes.
Yes, sir.
And can I write this as q by c into dq by dt? Can I write it like this?
Yes,
Yes.
sir.
Can I write this I as dq by dt?
Yeah.
है ना?
Yes, sir.
Can I write this as dq by dt? Common, taken common. This I and this dq by dt is taken common, okay? So L into di by dt is remaining in the first term, and in the second term it is remaining q by c equals to 0. Can dq by dt be 0? dq by dt is basically current. Can current be 0? No, right? So it's a
No,
non-zero
no.
quantity. So basically, if this is not equal to 0, then this should be equals to 0. Yes?
Yes, sir.
So can I write it as di by dt plus q by lc is equals to 0? Can I write it like this? Sir, why have you sent this L into denominator? Array, I have not sent this denominator in the, this was there like this. I divided the whole equation with L. When I divide the whole equation with L, automatically that L and this L will get cancelled out. And there will be one more L in the denominator over here. Yes?
Yes, sir.
Now can you see over here this di by dt? Can I write it as d by dt of dq by dt? Or can I write it as d2q by dt square? किसी को याद है? Double differentiation, है
Yeah.
ना? So can I write
Yes,
it
sir.
as d2q by dt square plus 1 by lc into q is equals to 0? Can I write it in this form? if I can write it in this form, anyone remembers what was the differential equation of SHM?
Yeah, the
Yeah, the differential equation of simple harmonic motion. Anyone? Was it equals to d2x by dt square, basically acceleration, plus omega square into x should be equals to 0. And this was acceleration is equals to minus of omega square x. ये सबको याद है क्या?
Yes,
Anyone
sir.
remember? है ना? So is it the same form? But what is the only
yeah,
difference?
same.
In place of x, I have q. So there, the position was changing different, according to that simple harmonic motion. Here, the charge is changing. So again, this is the same equation, the same differential equation of simple harmonic motion. So when I combine both of them, if it is like d2q by dt square plus omega square q is equals to 0. So can you see on comparison, omega square is equals to 1 by LC. And from here, omega square is 1 by LC. And from here, omega will be 1 by under root of LC. This is a derivation in your school. I don't think so they have given derivation. They have just given this direct.
Yes, they just gave it.
So omega is equals to 1 by under root of LC. लिख लो.
But this for resonance, right?
This is for no. अभी AC circuit is not there. Everything is happening in DC only, and here too there is no circuit like that.
Okay.
Here there is no supply. No, here just we had a charged capacitor connected across an inductor. No battery involved anywhere.
No battery, no resonance. So you're saying.
Exactly. Resonance happens when it's an AC supply. The
Okay.
source also
Sinusoidal, fine.
क्या बोल रही है principal?
Nothing.
The source also vibrates on certain frequency, in the case of resonance.
Yes, sir.
Here, though, there is no external source.
Hmm.
The battery needs. So omega is equals to 1 by under root of LC. And everyone knows this thing now. Omega is basically 2 pi by T or 2 pi F. सबको पता है formula. Everyone knows this, है ना?
Yes, sir.
Yes, sir.
ठीक है. So the angular frequency is this. So from here the time will be equals to, I can write this omega as 2 pi by T is equals to 1 by under root LC. And from here the time will be 2 pi into under root LC. Clear? Or from here I can write the frequency as well. Frequency will be 1 by 2 pi under root LC. Yes or no? So ये सब formula is clear है?
Yes, sir.
So now coming back to what was that T dash? Do you remember this T dash? Everyone remembers this T dash, right?
Yes, sir.
Yes, sir.
So please note this. After how many T dashes was this time period? 4
4
T
T
dash was equals to basically the time period, right? So basically, if someone asks you what is the time in which the energy will change its form, then T dash is the answer. So this will be T by 4 or 2 pi under root LC divided by 4. Clear? Is this clear, guys?
Yes, sir.
So लिख लो इतना. So now we solved that equation of SHM initially. So when we solved this equation, we got Q is equals to sine omega t plus alpha, right? Yes or no? X is equals to sine omega t, y is equals to a sine omega t plus alpha. So analogous to SHM, and log 2 SHM. Similarly, I can write Q is equals to the maximum charge. What was the maximum charge? The maximum charge was Q.
Mm.
And when we differentiate charge with respect to time, we get what? Current. Right?
Yeah.
So this will be equals to I naught sine, oh sorry, not sine, cos omega t plus. Okay. Just like we differentiated this, when we differentiated x with respect to time, we got v. Similarly, when we differentiated q with respect to time, we got I. Yes
So
or no?
it's the opposite in AC current. Why so?
It's the opposite in AC current. मतलब क्यों? क्या?
Like in the AC current chapter for
नहीं,
LC circuit.
in case of AC, even you can write it in form of cos. Sine and cos are interchangeable if you remember.
Yeah.
So, हाँ,
But
मतलब not interchangeable like this. You need to rotate it by a phase difference of 90 degree. है ना?
oh, there we get the equation as Q,
हाँ,
capital Q cos omega t, just omega
जी,
t.
जी.
Because it's a charge capacitor. So at t equal to 0, it's maximum charge. It has maximum charge.
Yes. Phasor diagram याद है सबको? Everyone
हाँ.
remembers phasor diagram from SHM last year.
Yes,
Yeah.
sir.
The same thing. And don't worry, new students. It's not necessary कि even sir you taught it last year, so I won't teach you this year. I'll again teach you phasor diagram. Okay? So that at least your AC chapter will be there. If your AC is good, automatically SHM becomes good. Okay? And vice versa.
Yes.
So anyways, done. Shall I start giving you questions?
Yes, sir.
Acha, there was one more relation of velocity with this thing, no? Anyone remembers this relation with velocity and charge, velocity and displacement? ये याद है क्या आपको? Everyone, do you remember this relation was also there? So the same
Omega
relation.
square minus x square 1.
The omega square under root of this. Hey, sorry, my bad. I'm very, very sorry. Omega bahar, a square minus y square. I'm sorry, you know. So here also I will be equals to omega into under root of I naught square minus q square minus q square. The total charge, the maximum possible charge minus the instantaneous charge. So there is a relationship between them as well. So ये भी याद रखना थोड़ा सा, ये भी काम कीजिए. Now question. The maximum charge on the capacitor is 100 microcoulomb. L value is 40 millihenry. Capacitor की value जो है वो 100 microfarad है. Now the question is determine the equation of instantaneous charge on the capacitor and instantaneous current. The circuit. So basically you need to only calculate omega, and already given the equations are just written above. Okay, everyone can see the equations written just above, right?
Yes, sir.
Sir.
Although you need to calculate the maximum value of current I naught, I naught also there is somewhere mentioned. So calculate everything, give me your answer fatapat. Hello guys, can you hear me?
Yes, sir.
Is that? Ajay, what is the omega? Guys, what is the omega? We know omega is 1 upon under root of LC. So this will be 1 upon under root of L is 40 milli Henry and C is 100 microfarad. So this will be अरे solve करो ना. I'll multiply this with this, so it will become -2. -2 minus 6 will become -4 out of the root, and this will be 400. 400 is 20, right? So 1 upon 20 into this, or basically into 10 to the power 3 ऊपर, और ये हो गया 1 upon 0.5. तो ये 500 रेडियन पर सेकंड आ गया.
Yes.
Omega is basically this. Now बस बचा क्या है जीवन में? What is the charge? Charge will be equals to, what was the maximum charge? 100 microcoulomb.
100 micro.
So 100 microcoulomb into sine of omega t. Alpha and phi are basically optional, no? I told you, no? Phi was optional. It was phase. If initially कभी लिखना हो तो लिख दो, नहीं लिखना हो तो it's fine.
So shouldn't it be 50?
क्यों?
That 110 to the power minus 2 will cancel here.
कहाँ पे?
And then will be minus 3. 10 to the power minus 3.
100.
No way.
हाँ ठीक है ना, ठीक है, हो जाएगा, तो भी हो जाएगा. 10 to the ultimately answer will come this, no?
Okay, let me check.
There is 4. There is
Yes.
one 4 as well. है ना? Don't forget about this 4.
Yeah, okay. Sorry, sir.
And I will be equals to I naught. Can you calculate I naught?
So
अच्छा, by
it's
the way,
0.05.
I naught will be Q into omega, है ना? ये ध्यान देना. Can you see over here? एक second. Let me go up. Q by under root of LC. And can you see 1 by under root LC is nothing but omega? So,
Yes, sir.
एक और फॉर्मूला भी है अपने पास, तो it's not necessary. Q is 100 microcoulomb and omega is 500 radian per second into cos omega t. Okay. So I think हो जाएगा guys, है ना? Shall I give you next? This question is nice. A figure is given, a circuit given like this. Can you see one inductor, two capacitor connected in a circuit like this, where there are two switches? Okay. Now question, this thing is, initially the 900 microfarad capacitor is charged to 100 volt and 100 microfarad capacitor is uncharged. Okay. अब क्या किया? Switch S2, the S2 one, the one which is with 900, that switch S2 is closed for a time t1. After which it is opened. And at the same instant, S1 is closed. जिस instant पे we opened S2, at that same instant S1 is closed. And we kept it closed for a time. Further time T2. Okay. And then open. Observe, when we did that, we found that the 100 microfarad capacitor is charged to 300 volts Now the question is, find the ratio of minimum possible values of time interval t1 and t2. Okay, please note the question very carefully and then start solving. It will take you at least 5 minutes to analyze this कि करना क्या है, और उसके बाद में you'll start doing it. So you can have your discussions. I'm here. Please discuss it among yourselves and tell me how will you do it, or discuss it with me, no problem. I'm giving you time for discussion. Think everyone, है ना?
Scroll it a little up for the diagram once again.
I'll just do this. Okay.
Yes, sir. Thank you.
चलो discuss करो. Tell me what are your thoughts on this type of problem. Think. But करने से पहले एक बार मुझसे पूछना कि sir, what to do in this question. अच्छा, can you see over here? It's purely an LC oscillation kind of thingy. At one time, only one switch is closed. Hello.
Yes, sir.
At one time, only one switch was closed. So is it two LC circuits at a time? है ना? At one time, one circuit is there. At another time, another circuit is there. So ultimately, we know कि इसमें LC oscillations will be used, right? Now, where will you begin with? I'll give you a hint. Start thinking in terms of energy, because we know there is no energy lost anywhere. No, is there energy lost anywhere?
No.
No, sir.
So फटाफट tell me. आज LC oscillations के साथ में will finish off the whole EMI. I told you, there is only one part which is left, induced electric field. That is purely based on J advanced, right? Not even there in mains. So we'll do that at advanced time. Okay. Acha, I never had a head count how many people are J and how many people are NEET. Okay, by NEET people, how many are there? Let me count. Able is J. Arya, are you J or NEET? Giving J or NEET?
Sir, J.
J. So two people J. There is J. Darshana. Darshana, are you giving NEET or J?
NEET.
NEET. Okay. J3, NEET 1. Ishita, NEET, NEET 2. Guru also NEET. Now it's equal. Joysha, NEET. Right?
Yes, sir.
Okay. So 4 NEET and Mridul is J. 4 J हो गया. Navina, what about you?
So, like I want to give NEET, but I don't know if I have to try JE also. So
Acha, you will give both.
I'm not sure. I mean, NEET, I'm like preparing for NEET. JEE, like I'm
Main
not
focus
really.
main focus is on what? NEET or JEE?
NEET.
तो मतलब 5 NEET now है ना, 5 NEET नहीं 6 NEET now. Ovia is also NEET, Pavitra is also NEET, Shrishma is JEE, right? Vedehi is JEE. So almost half is like this only, no? NEET people are 7 or 8 NEET people are there,
So
and
Satvik also.
Satvik also is JEE. मतलब almost half is there ना. चलो good, अच्छा रहेगा. And if you people score good, no, मेरी तरफ से chocolate हर एक को. Those who will get 98 percentile above in JEE will get a chocolate from me and a 100 dirham voucher, है ना. और NEET में those who get how many marks above? The total paper is 900 marks, right?
So 720.
720.
720. So
720.
those who will get 600 above. I know I'm setting a goal higher for NEET people, but those who will get 600 above, those will get the same thing. मेरी तरफ से. इंस्टीट्यूट पे अप्रिशिएशन होगा वो अलग चीज है, पर करना जरूरी है ना. एवरीवन हैज टू गिव दिस एग्जाम और स्कोर गुड. Because you people will be the result, the face of Asha. Ask her it is.
So this year there was JEE Center in Dubai.
This year there was
Was there JEE Center in Dubai?
no yaar. नहीं, for first attempt yes there was.
No, this attempt.
This attempt नहीं. अभी तो I don't think so. But there should be. There should be because it's online, no. So there should be an attempt for this also.
So did Kavya give second attempt?
No. She left it for those exams. What do we call it? AP. University level exams.
So AP exams. AP exam over.
हाँ तो she
What?
scored good. अरे एक
Oh, okay.
हाँ वो ओवर है ना, उसमें सिलेक्ट भी हो गई. She has got a good college now. So don't do this, ना. You people keep your options open. That doesn't mean कि you have to skip JEE and all. JEE देना है, वैदेही है ना, तेरे से बात कर रहा हूँ.
What, sir?
I am talking to you. If you are giving some other exam, that doesn't mean कि you don't give JEE and all. You have to give JEE.
No, sir. I am
हाँ
JEE focus.
ठीक है. सात्विक का थोड़ा मेरे को ऐसा लगता है सात्विक इतना श्योर है ना. सात्विक इतना दे, सात्विक से चलो बाद में बात रहेगी. चलो एनीवेज करा कुछ. Let's calculate. See, what is the initial energy? Let me just what is the initial energy in 900 microfarad capacitor? Can you see it was charged to 100 volts, right? So energy in this is half CV square. So half 900 into 10 to the power minus 6, and V square is 100 square. Yes or no?
Yes, sir.
So this
4.5 joule.
4.5 joule will be the energy in 900 microfarad capacity. And what is the final energy stored in 100 microfarad capacitor? U2, will it be equals to half CV square, and this will be half 100 into 10 to the power minus 6, and it was found to be how much? 300 square, right?
300.
So can you see when you calculate it, it will be also 4.5 joules.
Yes, sir.
है ना? So इसका मतलब क्या हुआ? What do you interpret from this data? कि when switch S2 was closed, all the electric field energy over here got converted to Magnetic field energy.
Magnetic
And
field
when this
energy.
S1 was closed, then all the magnetic field energy got converted to
Electric
100.
field.
So basically क्या हो रहा है? Entire energy is getting converted. So whenever there is entire energy getting converted, then automatically the time period in which one form of energy, can you see magnetic energy
T
कहाँ गया है?
dash.
हाँ, यहाँ से यहाँ तक magnetic field energy is getting transferred, right? So this
Yes,
time will
sir.
be T dash, and this time also will be T dash, but this T dash will be different. This T dash will be different. Are you getting my point?
Yes, sir.
So basically, you can write over here in an LC circuit. Here, what will happen? Here क्या बोल दूँ मैं? The complete energy transfer takes place. Complete energy transfer. This was a question which was asked in JEE Advanced. So basically, you need to analyze. Will take place. इतना difficult था क्या? Was it this difficult? Although the language was very big, कि हमारा इतना बड़ा question है. But no, you just start with whatever is given to you. What things were given to you? This energy was given to you, and this energy was given to you. Yes or no? मतलब ultimately the tools to find out this energy was given to you, and we know in LC circuit the total energy remains constant. ये पता था आपने? Take place in how much time? In T by 4. So basically it is equals to 2 pi under root LC by 4. Yes or no? So can I say T1 will be basically 2 pi under root of the, what was the value of L? 10 Henry, na? So 10, and capacitor was basically 900 microfarad. And second case divided by 4. And T2 should be 2 pi into 10. So what will be the ratio of T1 is to T2? Can you see everything else will get cancelled out? Here it will be under root of 900 upon under root of 100, which is basically 3. Answer. Numerical based question. Okay.
Yes, sir.
So this is minimum time. What about the maximum?
What about the maximum? Matlab?
Here they ask minimum, yeah, minimum time ratio. So can there be maximum time also?
No, minimum time ratio is basically 3. अब 3 से छोटा क्या होगा?
Okay.
Shall I give you one more question? This is this S1, this is this S2, this is L, this is 2L, this is C, this is 2C. The charge on this is plus 2Q, the charge on this is minus 2Q, and here the charge is plus Q, and here it is minus Q. So the question is, in the circuit shown in the figure, if switches S1 and S2 are present, find the oscillator frequency of charge in this circuit. You need to find out the frequency in the circuit. Find the frequency, oscillating frequency of the circuit first when only S1 is closed, second when only S2 is closed, and third when both S1 and S2 are closed.
Sir, I had one doubt related to
बोलो
capacitance.
बोलो.
हमें यही मानना होता है राइट कि जब करंट फ्लो कर रहा होता है तो वो एक प्लेट से इलेक्ट्रॉन्स निकालता है और दूसरे प्लेट पे डिपॉजिट करता है राइट. तो जिस तरफ से या जिस प्लेट से करंट निकल रहा है वो पॉजिटिव होगा राइट.
Correct. Because that will be at higher potential.
एंड अगर कैपेसिटर डिस्चार्ज हो जाए और उसके बाद भी करंट फ्लो करे फिर क्या होगा.
जब कैपेसिटर डिस्चार्ज हो जाएगा उसके बाद तेरे को लगता है करंट फ्लो होगा.
ये बट इंडक्टर भी है साथ में. इंडक्टर पूरा चार्ज लाइक उसमें मैग्नेटिक एनर्जी मैक्सिमम पॉसिबल मैग्नेटिक एनर्जी स्टोर हो चुकी है.
करेक्ट.
तो फिर क्या होगा जब कैपेसिटर डिस्चार्ज होगा.
कैपेसिटर डिस्चार्ज होगा तो फिर इंडक्टर एनर्जी सेंड करने लग जाएगा ना.
ओके. और प्लेट्स की पोलैरिटी रिवर्स हो जाएगी.
जस्ट कंसिडर इसका एक ऐसा तो कंसिडर कर ले. पहले तेरे पास कैपेसिटर है ना. कैपेसिटर एंड इंडक्टर दे बोथ आर प्लेस्ड इन अ तराजू. व्हाट डू यू कॉल अ तराजू इन इंग्लिश? बैलेंस, बीम बैलेंस है ना. अब one side there is this capacitor and one side there is inductor. Initially let's say I have capacitor and I have poured all the energy in the capacitor है ना. Now what is happening, this energy can go to the inductor by inner source है ना. So basically क्या होगा, इस capacitor से energy will keep on reducing and inductor में keep on filling. So similarly, हाँ, फिर ऐसे once all the energy of the capacitor has been drained, it will be shifted to the other side on the inductor side. और फिर बाद में again the same thing will happen because it will never stop.
But sir, the direction of current will be the same, right? So how can the polarity of the plates be changed?
Direction of current दो cycle मतलब 2 quarter cycle तक same रहता है. After the second quarter cycle it changes because now the capacitor when it becomes charged again, वो opposite direction में it gets charged.
Okay, got it.
हाँ जी. When only S1 is closed, will there be any role of this second capacitor? So what will be the frequency? The frequency formula is given by 1 by 2 pi under root of LC, right? So then the first case, the frequency will be 1 by 2 pi under root of L and 2L. Can you see this inductor and this inductor are in series? So what will be the net? Net. And what is the capacitance? It will be C. So this is the answer for the first case. What is the answer for the second case? Under root of. Again, this will be 3L. And what will be the answer for the second case? It will be 2C.
So S2 is closed, right?
When S1 is closed, only S1 is closed, only S2 is closed is this.
So it's only capacitor system. How will inductor come in?
Inductor तो already is there over here, no? Inductor
No,
doesn't
but
have...
S1 is open, right?
हाँ, initially if S1 is open, अच्छा ऐसा. Okay, sorry, my bad. Delete. Sorry, my bad. Okay. Now is it fine?
Yes, sir.
Okay, sir.
Okay. I understood your doubt. Ki sir, S1 is still closed. Then how is the whole thing oscillating? Correct. And what will happen if both are closed? If both are closed, then what will happen? You need to consider the capacitance of both. Now this C and this 2C are in parallel. And in case of capacitance, this will become added. We'll add it. So F3 will be basically what? 1 upon 2 pi under root of 3L into 3C. And that's the answer to your question. ठीक है?
Yes, sir.
Shall I give you next?
Yeah.
क्लास कब तक रहती है?
So till 4.
So shall I give you one homework question? कि नहीं, you will do this question in class. ये वाला अच्छा है. I could have given this as homework. And this is given to you. The initial charge on the capacitor is 200 microcoulomb. The inductance of is 0.2 millihenry, and the capacitance is 2 microfarad. Now the question is, if at t equals to 0 the switch was closed, then find the first instant. Find the first instant when energy stored in inductor becomes 1/3 of that of capacitor. Okay, so basically what is the only thing you need to find out? That time instant when the you need to find out an instant when this thing happens. The potential energy stored in the inductor is basically 1/3 of that. ठीक है, शुरू हो जाओ. Satvik is not there. Who else is not there? Shrish is also not there, no? Chali. How will you do it? See, we know this particular thing, है ना? And we also know this particular thing, that the energy stored in the capacitor and the energy stored in the inductor should be equals to what? The total energy.
Q square by 2C.
Correct? Right or wrong? So can
Yes,
you
sir.
see from here, I can write this as 1/3 times of UC plus UC is equals to Q square by 2C. And I can write this as 4/3 times of UC. And from here, can I write 4/3 times of half small q square by c is equals to Q square by 2C? Well, what is Q? Q is the general charge at that instant, right? Yes or no?
Yes, sir.
So can you see over here, this 2C and 2C will get cancelled, and from here the small q will be, sorry, under root of 3 by 4 times of q, or I can write it as root 3 by 2 times of q. Yes? Yes or no? And by the equation of time we know, by the equation of charge we know this thing, q is equals to q sine omega t. So from here q को I can write it as root 3 by 2q is equals to q sine omega t. From here ये और ये कट जाएगा, sin omega t root 3 by 2, that implies omega t is how much?
Pi by 4, pi by 3.
Pi by 3, 60 degree. 60 degree can also be written as pi by 3 radians. Everyone knows this, है ना? So omega t will be equals to, or basically you can write t is equals to pi by 3 upon omega, and omega I can calculate. Yes or no? Can you calculate omega?
Yes, sir.
1 by under root of LC. So ये calculate करके you will put it over here, and that's the answer. Is this clear?
So can you please scroll up?
Sure. यहाँ पे ये और अब
No, sir, no, sir. This one, this one.
Okay guys, we'll see you again in the next class, and with this thing I'm done with electromagnetic induction. Okay?
So,
Yes.
so can you explain this answer again and understand why
Okay.
it is 4 by 3?
Why it is 4 by 3? Because 1 by 3 plus 1 is how much? 4 by 3.
Oh,
1 by 3
like
UC.
that.
UC plus UC by 3 becomes 4 by 3.
Okay.
And then 4 by 3, and we wrote this UC as a general energy stored in the capacitor, so half q square by 6.
Okay, sir.
Anything else? Sorry guys, in the next class we'll do what?
Magnetism and matter.
Magnetism and matter. ठीक है. And after that we need to do electromagnetic induction. Electromagnetic waves. Electromagnetic waves is easy, and it's a very small chapter. Okay, so in 1 or 2 lectures only it will get completed. So don't think like sir electromagnetic waves आपने पढ़ाया नहीं है. नहीं, वो बहुत छोटा सा chapter है. It's a very small chapter. Okay.
Okay, sir.
चलो ठीक है guys, thank you very much. We'll see you again in the next class, and we'll start with a new chapter, magnetism and matter.
Thank you, sir.
Okay. अच्छा, by the way, school में क्या syllabus चल रहा है? What is the syllabus going on?
The AC.